Hello students, we know the properties of all types of quadrilateral, that is parallelogram, square, rectangle, kite and trapezium. Now today we are going to learn about the next part, that is theorem of midpoint of two sides of triangle. The statement of this theorem is the segment joining midpoints of any two sides. The segment joining midpoints of any two sides of a triangle is parallel to the third side and half of it. This here we are learning about the midpoint of the triangle. We are learning here triangle. The segment joining midpoints of any two sides of a triangle is parallel, means that segment is parallel to the third side of the triangle and that segment is also half of the third side. Now from here, from the statement, we can first we have to draw the figure, then only we can understand what is given, what is proved. So here the statement, first we have to draw the triangle. We have to draw the triangle according to this information only, according to this statement only. So see here, this is triangle A, B, C. Triangle A, B, C and midpoints of this triangle. The segment joining midpoint of any two sides. Now here we are taking the midpoint of side AB is P and midpoint of side AC is Q. Now we have to join this segment. And this segment is parallel. We have to prove this. This segment is parallel to the third side of triangle and it is also half of this third side, that is PQ is half of BC only. Now first we have to write here given in triangle ABC, in triangle ABC, P is midpoint of side AB and Q is midpoint of side AC. P is midpoint of side AB and Q is midpoint of side AC. That's why here AP is equal to PB and AQ is equal to QC. Now we have to prove this. Midpoint of any two sides of triangle is parallel to the third side. Is parallel means we have to prove this. So to prove PQ is parallel to BC. That is first part, and second part is there. It is half of, so PQ is half of BC. PQ is half of BC. So we have to do the construction for this. We have to proceed PQ line. We have to proceed PQ line such that PQ is equal to QR. PQ is equal to QR. And we have to join this R and C. We have to join this R and C. So here we have to write or produce segment line PQ till R such that PQ is equal to QR and draw RC or join RC. We can write in this way also. Now we have to write the proof for this. We have to prove this now. This segment PQ is half of BC and PQ is also parallel to line segment BC, which is the third side of the triangle. Now here we got two triangle APQ and QRC or CRQ. So we can write here in triangle APQ and triangle CRQ AQ is equal to segment AQ is equal to or is congruent to segment QC. It is given only. And PQ, segment PQ is congruent to segment QR. That is the construction. And angle AQP is congruent to angle AQP is congruent to angle CQR, that is vertically opposite. And therefore triangle AQP or APQ, any APQ is congruent to triangle APQ is congruent to CRQ, is congruent to triangle CRQ by SAS test, because two sides and included angle of one triangle is congruent to the corresponding two sides and included angle of the another triangle. That's why these two triangles are congruent by SAS test. When these two triangles are congruent, then the remaining sides and remaining angles are also congruent. Therefore, we can write here angle PAQ, this angle PAQ is congruent to angle RCQ, and we have to write CACT, corresponding angle of congruent triangle. And segment or side. Now here AP is congruent to RC. Segment AP is congruent to segment RC or CR. CSCT. Now here we have to write 1 and here it is 2. 1 and 2. Now here we are understanding when two triangles are congruent by any test, then the remaining sides and remaining angles are also congruent. So from 1 here, when this angle PAQ means this angle and angle RCQ means this angle, these two angles we can see here. Here we showed that these two angles are congruent. CACT, corresponding angles of congruent triangle, and we can see here these two angles are alternate angles. These two angles means this is a pair of alternate angle. So we can write here, therefore angle PAQ from 1, we can write angle PAQ is congruent to angle RCQ, and result alternate angle test. Alternate angle. Alternate angles. Therefore, here segment AP is congruent to segment CR. Here it is given segment AP congruent to segment RC from 2. And now you can see here AP is congruent to segment RC, and this angle is congruent to this angle. Means here we can understand here, if this side is AP is congruent to RC, and we know that AP is congruent to PB because P is the midpoint of AB only. P is the midpoint of AB. So when AP is congruent to RC, means PB is also congruent to RC. This only we have to write. Now we can write here segment AP. Segment AP is congruent to segment PB is congruent to segment RC or CR. RC or CR, and PB is parallel, and PB means here this is parallel because AB is parallel. PB is parallel to RC. PB is parallel to RC or CR. Therefore quadrilateral. Now see here. Segment AP is parallel. Segment AP is congruent to PB, and it is also congruent to RC. Means here we got PB is congruent to RC, and PB is parallel to RC. PB is parallel to RC, and therefore here we are getting this PBCR is a quadrilateral. Here we are getting this quadrilateral, which is a parallelogram because opposite sides are parallel and congruent also. Opposite sides are parallel and congruent. That's why quadrilateral PBRC, PBCR is a parallelogram. Is a parallelogram. Is a parallelogram. And when it is a parallelogram, then PQ is parallel. Now here, then here, if this side is parallel to this side, and this is a pair of which is a pair of congruent side, so this side is also parallel to this side. Therefore PQ is parallel, or PR is parallel to BC, means PQ is parallel to BC because PQR are collinear. Therefore PQ is parallel to BC. PQ is parallel to BC, and PR is equal to BC, and PR is equal to or congruent to BC. PR is congruent or equal to BC. Opposite sides are congruent. Here we have to write when it is a parallelogram, and we know the property. When it is a parallelogram, then the opposite sides are parallel and equal. Opposite sides, and therefore now one part we proved here. First, BQ is parallel to BC. BQ is parallel to BC, and PR is equal to BC. Therefore PQ or 2PQ, PQ is half of PR. PQ is half of PR. Therefore PQ is half of BC because PR, and here we showed that PR is equal to BC. Here I will write 1, 2, 3. So from 3. 3 because PR and BC both are equal, which are the opposite sides of parallelogram. I hope you have understood this theorem, which is theorem of midpoint of two sides of triangle. Thank you, students.